Hello there, ladies and gentlemen, and welcome to another video. Now this is going to be like part 3 of this macropad kind of videos. So in the first pad I showed you the hardware calculator, well, like the hardware calculator feature, which is basically, so if you do like say 12 plus 12 and then press equals here, it will print out the result. So that's the hardware kind of calculator feature. And then next video I did like a description of how I built the thing. So as you can see, originally it was a hardware or a hard drive case and so on. And then in this video, I'm gonna show you guys like how to flash the firmware and then kind of like some code guide, I suppose. So since this is using a QMK firmware, inside the config.h you can see like how the pins are connected to the Pro Micro. So as you can see here, each pin has like a different number, and you can get these from a website. So if you just Google Arduino Pro Micro pin layout or whatever. So I'll try to make this bigger so you guys can see. All right, so anyway, here is the layout for the actual calculations or the parsing of the inputs. I use the tinyexpr. So what this is, if I open up a Firefox window here, now we can search for that. It should be on GitHub. Yeah, there we go. So I used this library. It's a masked expression parser, and I had to strip it out a good bit because by default the full size of this library doesn't like fit on the firmware, basically, because it's quite big. So I stripped out like all the kind of log functions and everything that I won't really need in my layout anyway. To compile this, you basically, so there's kind of two key maps. There's the default and then there's the minimized. The default key map has the full tinyexpr library. So if you scroll down here, the tinyexpr functions, it's all here. And this is basically the full library. So if you want to like add your own kind of functions or whatever, you can do it through here. But this one here, if I scroll down to the functions, I stripped out like all the kind of unnecessary stuff, so it's a lot smaller and fits on the firmware just fine. There's probably some more stuff I can strip out here, but the firmware size is okay for now. So how this actually works is, if you go to the layout, so here is my calculator layout here, and all of these buttons are basically macros. So I just stashed them in here in custom key codes. And as you can see, what it's doing here, it's writing like the character 1 to the buffer. So if we go to this function here, okay, so I actually have it like at the bottom, or I think I could just go to definition. Yeah, so there it is. So what it's doing is it's just entering the character into my expressions buffer and then terminating with the null character, because this is needed for the tinyexpr library. It needs to be like in an IC string with null terminated character. So if we go to the expression buffer, it is just a char array with 64 elements in it. So I think 64, you would never really reach that for calculations, so that's why I chose that. So yeah, there is, there's also kind of like auto clicker functions. So this will be the same for my mouse build. Well, like similar enough code. So this is in the mouse layer, and how that works is, first of all, we would need to enable it. So that's done inside macros as well, macro feature. And yeah, so there it is. So we just toggle a boolean here, and then we go back into the matrix user scan. So what this function is, it runs like endlessly, so we can like put code in here, and you can actually execute like key codes here. So this is exactly what we're doing. So we're checking if the auto clicker is enabled, and if we're holding it, or if the AFK kind of auto clicker is enabled. So basically this mode here is if you enable the kind of like tapping. So if while you're holding the mouse button down, it like auto clicks, whereas this one you don't need to hold the mouse button down, it just keeps on clicking basically. So here what we do is we increment our timer, because if we send a key code like all the time without a delay, what will happen is the program will freeze up. Well, at least that's what happens for me. So like if you're auto clicking in the browser or whatever, the browser will kind of get stuck until you stop the auto clicker. So yeah, this just adds like kind of safety delay so that not too many key codes are sent at the same time basically. So this checks if the timer has reached the maximum timer, and what that is, I think I changed, I set it to like 100 or something. Yeah, so I set it to 100. So basically it sleeps for like 100 cycles of this function. And then if it's greater than 100, it'll reset the timer variable to 0. And so next time this function is run, it will be 1, so it'll press the mouse button. So that's kind of how that works. Let's see what else is here that's interesting. Oh yeah, I suppose if I so if I'm like typing something, I'll just go into the camera desktop. So if I'm typing like say 12 plus 12 plus 12 plus 12, and then I want to know what I'm typing out, so I press this key here to type out the whatever is in variable basic, or whatever is in the buffer, then whatever that is, 48. So how that works is actually fairly straightforward, since we are using this expressions buffer to store all of our inputs. So basically you get a string which the library will evaluate to a result. So yeah, so for the key code is print equation. So as you can see here, that's at the very top, that's where like the kind of numlock is. And if we go down here to print equation, basically we just use the QMK send string macro. So send string basically, well, like normally how you'd use this is you would have, I don't know, like whatever you want. You can have like your password here even if you wanted to, and then you can also do like pressing the shift key and all that kind of stuff. You can do delays and all that kind of stuff. with this function as well. But for now, I just use it to send out the buffer. And since when we build the buffer, we always add a null terminator character at the end of the buffer, that way it's safe to print at any moment. So yeah, that's kind of a... Oh yeah, and also I forgot to mention how to actually flash the firmware. So you have this big ass command here. Now first thing you want to do is you want to find out which port the Arduino is listening on. So to do this, you will run sudo, well, you'd plug out the macropad, plug it back in, and also reset it to flashing mode. So to reset it to flashing mode, what you want to do is you want to get like a screwdriver or something, and then you want to short pins 2 and 3. So just skip the first one and then kind of like put the screwdriver on pins 2 and 3. And this is from, so the USB is going out that way. So it's just 2 and 3 here. So this will give you, I think it's like 8 seconds. So if you don't like flash it within 8 seconds, you'll have to short it again. But once you get that, once you plug it in and run this command, and it'll give you the output of like the last USB that you inserted. So it should be something like this. It'll probably be this if you're on Linux. On Windows, I think it's like COM2 or something, COM1, I don't know. So yeah, you want to run this as a sudo avr dude. So you need to have the avr bin utils installed for this. And so just copy the command here. So this is all the same, and then up onto here, this is the file that QMK generates after you compile. So this will be inside the QMK kind of root directory. So after you run this command to compile the firmware, you will have this file. So you just stick this file at the end of this command, or whatever ones you use. And so yeah, that's it. It's kind of like the code kind of thing, like how I did it or whatever. So yeah, thanks for watching, and bye bye.